I'm recording now. Sorry. Okay, so all right, for number 13, we have the limit as x approaches 0 of 2 minus square root of 4 plus x all over x. So if I plug in 0, we get 0 in the denominator, which is the problem. Since we have that square root, the only way of finding this limit is to apply the conjugate method. So you're going to multiply both the numerator and the denominator by the conjugate of the radical. So that's the 2 minus the square root of 4 plus x. So I'm going to multiply by 2 plus the square root of 4 plus x. So the only sign that you're switching is the sign that is between this right here, this middle sign. You don't actually switch anything within the radical. Is that cool? All right. So now we're going to multiply everything. When you're using the conjugate method, I don't know if you remember, you only have to multiply the conjugates together. Don't multiply, in this case, the denominator. Like, don't distribute that x, okay? Because eventually what we're going to do is we're going to cancel something. So distribute the 2, and we get 4 minus, plus 2 square root of 4 plus x. Now I'm going to distribute the negative square root, so that would be negative 2 square root of 4 plus x minus, and then the square root of 4 plus x times the square root of 4 plus x would just be 4 plus x. But notice that I put it in parentheses because I have to remember that I'm going to distribute that negative because it's minus the product, so minus the entire product. Is that clear? Okay. All over x times 2 plus the square root of 4 plus x. When you multiply, and I multiplied everything out as a reminder that when you multiply conjugates, those middle terms should always cancel out. I have the positive 2 square root and then the negative 2 square root, so these go away. And then when I distribute this negative, what I end up with is this 4 here from the beginning, so 4, then minus 4 minus x all over x times 2 plus the square root of 4 plus x. So far, we're okay? Okay. The 4's cancel. And then I have negative x and c over x. That whole point of doing this is to be able to cancel out that problematic factor. So I can cancel out this x here as well. But I still have a negative in the numerator. So this is now negative 1 over 2 plus the square root of 4 plus x. Yeah? Now, once we've simplified, I can't do anything else. I look back at what I'm supposed to be plugging in, which is 0. I can now plug in the 0. So this would be negative 1 over 2 plus the square root of 4 plus 0, so 4. The square root of 4 is 2, so negative 1 over 2 plus 2 is negative 1 over 4. Yeah? Because here of this negative right here. So when we canceled out the x's, the numerator was negative x, so you still have that negative 1. Did you get that? Since I can't see you, you can just use the little thumbs up or whatever. Okay, cool. Alrighty. What else? Number 21. Let's go to number 20. I like that you guys are prepared. Okay, so the limit as h is approaching 0. First of all, if I see h, to me, that signals derivative. Do you get what I'm saying? So remember, and I always bring it up just because I want you to remember that limit definition, which is the limit as h approaches 0 of f of x plus h minus f of x all over h, and the answer to that limit is the derivative of your function, right? Okay, so if you see the limit where h is approaching 0, look at what you have. It would be f of x plus h. You see how you have 3 raised to the x plus h minus 3 to the x. This 3 to the x, this is f of x. Does that make sense? So I like to make a note. F of x is 3 to the x, not the negative, because that's part of the definition. So the answer to that limit is the derivative of this function. Is that okay? So this is an exponential where the base is not e, and the derivative of that is the ln of your base, which is 3, times the exponential itself, times the derivative of the exponent, which is just 1. So this is your answer. And that's like from knowing your derivatives of all different kinds of functions. The degree is the highest exponent because you see, wait, let me just make sure. Jenny, 21, okay? Okay, cool. Okay, no, you're good. So, they're the same because in the numerator, the highest term with the exponent is the x squared, right? But it's underneath the square root. So the square root of x squared is x. You get me? And in the denominator, it's x. So they do have the same degree because the degree of the numerator is 1, right? Because if I take that out of the square root, then it would just be x instead of x squared. Exactly. So you take your coefficients and you divide. Now the coefficient of the numerator is the square root of 4, which is 2, this part, over 1, because that's the coefficient of the denominator. Remember, when they have the same degree, okay, let's just make sure you understand the same degree part. Okay, when they have the same degree, when you're finding the limit as x approaches either negative infinity or positive infinity, you divide those coefficients. Okay, so the coefficient of this part here of the x squared is the square root of 4 because it's underneath the square root, which is 2. Yes. Well, you don't divide the degree, you divide the coefficients of the degree. By, yeah, so like here would be the negative 3 over 2. Yeah, 2, x. Here, okay. The only thing is that for this one, because it's as x is approaching negative infinity, um, if you divide your coefficients, you have to also pay attention to what the sign is going to be. So think of like plugging in infinity, like you take your largest, right? I'm going back here to the largest degree. If you plug in infinity, this would be the square root of 4 times negative infinity squared over negative infinity, right? Okay. The square root of 4 is 2. Now we know it's going to be 2 because of the 2 over 1. But because of that negative infinity, it should be negative 2. Homegirl, that's in our lesson. I know, we forget things. Yes. Yeah, but see, if you do the same thing, it's negative 3x to the third over 2x to the third, right? If you plug in infinity, negative infinity, because x is approaching negative infinity, it's negative 3 negative infinity to the third over 2 negative infinity to the third. Anything raised, like if anything negative raised to an odd exponent will remain negative. Okay, so this would be a negative times a negative, which would be a positive 3. And then 2, which is positive, times a negative would be negative 2. So it would still be negative 3 over 2. Okay, anything else on this page before moving on? Okay, what else? Number 29. And I can go back and forth. So if you have a question or something before, afterwards, just let me know. Okay, let's see. Let f be the piecewise function defined below. Which of the following statements are true? Okay, so if you look at 1 and 2, 1 and 2 are derivatives, okay? And it says f of 3 plus h minus f of 3 all over h is equal to 2. Now, what this is saying is this here, this means f prime of 3 equals 2. Remember that this is the definition of the derivative. This is from the left side. And then this would be from the right side. So also f prime of 3, but from the right. Okay, here this is my piecewise function. This is the left side, and this is the right side. Okay, now statement 3, it just has the general derivative, f prime of 3 is equal to 2. If in order for a limit, sorry, a derivative to exist, right? Like for a piecewise function, the left side and the right side, just like limits, have to equal to the same number. So what we're going to do is we're going to get the derivative of the left and the right. Okay, so f prime of x for the left side, which is the top, is 2. Yeah, f prime of x for the right side is also 2. So that means that statement 1 and statement 2 are correct. Yeah? Statement 3, f prime of 3 is equal to 2, that's if both the left and the right are equal. Since they're both equal and they equal to 2, then the derivative does equal to 2. So 1, 2, and 3. Mm-hmm. No, you're good. You're good. 61? Okay. Yeah, like I said, if you have questions on anything before, after, it doesn't matter. I can jump around. Okay. Find the derivatives of the following implicitly defined curves at the indicated coordinates. Okay, so for 61, this was like one of the last things we did, which was that implicit differentiation. Remember that when you're finding a derivative of an equation that has two variables, in this case x and y, then whenever you find the derivative of any term that has y, you're going to multiply it by dy dx. Okay, so for the first part here, we have x minus y. All of that is being squared. Okay, so I'm going to here apply the chain rule for this part. So that's going to be 2 We leave the x minus y alone, subtract 1 from the exponent, so that'll just be 1, times, now the derivative of the inside, which is 1, minus, and then the derivative of y is 1, and then we multiply it with dy dx. Exact. This one here? Yes, because that's the derivative of the x. So remember, you're finding the derivative of everything that's inside of that parentheses. Exactly. Okay. Now we're going to continue with our derivatives here. Plus the derivative of 3x is 3 is equal to, and then the derivative of negative 6y would be negative 6 dy dx. Is up to here okay? Okay. Now here's the only thing about this question is that we want to isolate the dy dx's at all times whenever we're solving for implicit functions. And here we have this dy dx inside of, we got to distribute all of this so that we can get that one term that has the dy dx and move it to the other side. Okay, so I'm going to distribute the 2 here. We got 2x minus 2y times 1 minus dy dx plus 3 is equal to negative 6 dy dx. Now we have to distribute all of this. Okay, so 2x times 1 is 2x, and then minus 2x dy dx minus 2y plus 2y dy dx. Then we have the plus 3 is equal to negative 6 dy dx. Oh, why are you doing that? Okay. Is this okay up to here? Yes. Yes. So remember that when we're doing implicit functions, we want to get all of the terms with dy dx over on one side, right? So that we can factor out that dy dx. The problem here with this one is that we have dy dx in this parentheses with another term. So we can't isolate it because we have all this other stuff that's being multiplied to it, right? We have the 2 and then the x minus y and then times all of this. Okay, so let's say if I were to, let's say, subtract this 3 and then divide, it's going to be a huge mess. You won't be able to get the dy dx by itself because we have it here on this side. Do you get what I'm saying? You see it now? Okay. So I just distributed everything. Like if it would be a little different if that one was not there. If the one was not there, then we can just move all of that over to the other side and then divide it. But I can't because of that one. Yeah, exactly. Okay. So now that I have all my dy dx's like basically distributed, we can move this term and this term over to the other side. Yeah. So on the left, what I have is this 2x minus 2y plus 3 is going to equal to, then on this side, I have the negative 6 dy dx. I'm going to add the 2x dy dx here to the other side, so that way I can cancel it out from this side. So plus 2x dy dx. And then this one I'm going to subtract over to the other side. So be minus 2y dy dx. So now all the dy dx's are on one side. Is that okay? Yes, no, maybe? Okay. So, all right. So once you have all your dy dx's on one side, you can factor out the dy dx. So we have 2x minus 2y plus 3 equals, I'm taking out the dy dx, so I have the negative 6 plus 2x minus 2y. Now I can divide by all of that over to the other side. So dy dx is going to equal to 2x minus 2y plus 3 divided by negative 6 plus 2x minus 2y. That's my derivative. So at this point, remember that the question is asking for the derivative at the particular point. So here the x is 1, the y is negative 2, we plug that in. So 2 times x is 1, so 2, minus 2 times y, which is negative 2, making it plus 4, plus 3, all over negative 6, plus 2 times 1, which is 2, minus 2 times negative 2, which would be plus 4. Is that okay? When we actually work this out, we get here 9 over 0, which is unfortunate. So this means that that particular derivative is undefined. Okay? Oh, okay. 69. If sine of x plus y is equal to 3x minus 2y, then dy dx. Okay, so this is another implicit. To find the derivative of sine of x plus y, that is cosine of x plus y, right? And then times the derivative of the angle, which is 1 plus dy dx. Okay, and that's going to equal to 3 minus 2 dy dx. Yeah? Okay. Same situation here as the last one. We can't isolate the dy dx from this side because of that 1 that's there. So I'm going to distribute the cosine. Is that okay? Okay. So cosine of x plus y times 1 is itself cosine of x plus y, and then plus cosine of x plus y dy dx is equal to 3 minus 2 dy dx. So far, so good? Yeah? Okay. I like to keep my dy dx's, if I can, on the left side. So I'm going to leave this one here, and I'm going to subtract this cosine of x plus y over to the other side. Okay. So let me just rewrite this a little bit so it looks cleaner. We got cosine of x plus y dy dx equals 3. I'm going to put the minus cosine of x plus y here, and then the minus 2 dy dx. Yeah? Now I want my dy dx's, so I'm going to add this to dy dx over to the other side. So that way, on the left now, we only have the dy dx's. Since on the left, That's all I got. I'm going to factor out that dy dx, which will leave me with cosine of x plus y plus 2 equals 3 minus cosine of x plus y. And then finally, you divide. So we're going to divide by all of this. And this is my derivative, which when you look at your option, that's option D. See in the numerator 3 minus cosine x plus y, and then 2 plus cosine x plus y, which is the same thing as cosine x plus y plus 2, just in a different order. Mm-hmm. After or before, what do you mean? Oh, okay, okay. So after, but you understand like adding the two dy dx. Okay, so this is the left side, right? It's the cosine of x plus y dy dx plus 2 dy dx, right? So what I did now is I kind of skipped a step in the sense of I didn't rewrite it, but they both have the dy dx, so I factored it out. And then what I had left was the cosine of x plus y, and then the plus 2. That's okay. Yeah, you're welcome. Yep. Let's see. Yes. Okay. So let f of x equal to x to the third minus 5x squared minus 8, and let g be the inverse of f. Okay. So g is equal to the inverse, right? Okay. This number here, this is the x value of the inverse, which is the y value of your function. So you're going to make x to the third minus 5x squared minus 8 equal to negative 12. Okay, now in order to solve for x, a lot of the times these questions, especially like a question like this one, is without a calculator. So you gotta kind of start testing some numbers and see what would work. So let's say if I always just start with 1 and I'm gonna see does 1 work, right, to figure out what the x is. If I plug in 1, that would be 1 minus 5 minus 8 equals negative 12. 1 minus 5 is negative 4, minus 8 is negative 12. So x is equal to 1, right? And the reason why I do that is because this is going to equal to 1 over f prime of this number, which is the 1. You get me? So, oh, just kidding. Find g of negative 12, that's x is equal to 1. That's the answer for 63. Sorry, I broke it down. Now g prime of negative 12, that is what's going to equal to 1 over f prime of 1. Okay, I know it's because they like to change instead of using the inverse notation, they like to be like, oh, g is the inverse of that. But it might be helpful if you see it like this. G prime of negative 12 is saying f negative, like f inverse of negative 12 prime, right? This is the exact same thing, which is going to equal to 1 over f prime of the value that we got, which is the 1. Yeah, I know. Yeah. So then you take the derivative of f of x, right? So f prime of x would be 3x squared minus 10x. And then you plug in the 1. So it'll be 3 minus 10, which is negative 7. So g prime of negative 12 is going to be 1 over negative 7, which is negative 1 over 7. Okay, what else? Yes. 47. This is, okay. Okay, so the derivative for this one. When we first look at that, remember the derivative of any ln function is the derivative of the numerator, is the derivative of your ln, whatever is inside of ln, over the original, right? So like, let's say if you wanted the derivative of the ln of 3x squared, this would be 6x over 3x squared, right? Okay, the problem here is that we have not only a fraction, but we have that fourth root. So instead of trying to find the derivative of all of that, because you have to use a chain rule, and then you have to use the quotient rule, and it's really long and annoying, we're going to use the properties of ln. So another way of rewriting this is the ln of x squared plus 1 over x squared minus 1 raised to the 1/4, right? Okay. According to properties of ln, whatever exponent is here, right? If everything inside of ln is raised to that exponent, it can be moved to the front and it becomes a coefficient. So that's 1/4 ln of x squared plus 1 over x squared minus 1, right? Additionally, another property of ln is when you have division, you can expand it and it would be subtraction. So this is 1/4 of ln of x squared plus 1 minus the ln of x squared minus 1. Always the numerator and then minus the ln of the denominator. Does that make sense? And that 1/4 here, that applies to everything, to both of those lengths. So I have it like the 1/4 on the outside. You can also have written it as 1/4 ln of x squared plus 1 minus 1/4 ln of x squared minus 1. However you choose to write it is fine. They're the same thing. Is that okay? Okay. Now we can take the derivative of each piece individually, and that's going to make it a lot easier. So, for example, with this first part, we have the 1/4. Remember, coefficients tag along. The derivative of x squared plus 1 is 2x, and then you're going to put it over the original, so x squared plus 1, minus, now I do the same thing here for the second part. We have the 1/4. The derivative of the numerator is 2x over x squared minus 1. Is that clear? So, um, you can, however you decide you want to write this out. I don't remember how I have it in the answer key, but since there's so many questions, don't stress over simplifying this too much. You can leave it as just like this. Is that okay? Because the main thing I wanted from this question is for you to remember those properties of ln. All right. Mhm. No, no, no. There's no unit circle here because of what's it called? It's not trig. But let's start from the beginning, right? Does anybody else have questions on this one? Okay, all right. Yeah, so let's just start from the beginning. All right, so you would have to use the product rule here in order to get the derivative, because if you want to know where it's increasing, you need those critical numbers. So it's this times this. So we're going to do the product rule. I'm going to start up here so I have space. The derivative of x plus x squared would be 1 plus 2x, and then raised to times e to the negative 2x, plus, now it's x plus x squared, and then times the derivative of e to the negative 2x would be negative 2e to the negative 2x. Is that okay so far? So what I'm going to do here is I'm going to simplify this a little bit. This is going to be 1 plus 2x e to the negative 2x. I'm going to move this negative 2 to the front. So this will be minus 2x plus x squared e to the negative 2x. Is this okay that I did that? Okay. To find your critical numbers for this, that's when this is going to equal to 0. The critical numbers is a little bit tricky to find. So what I did is that since both terms have e to the negative 2x, I factored it out so I don't have to think about it too much. I factored out the e to the negative 2x, which leaves me with the 1 plus 2x here, and then minus 2x plus x squared. So this was left over, and then this was left over once I took out the e to the negative 2x. Is that okay? Okay. The one thing that you need to know about e never equals to 0. Okay, it's never going to actually touch the y is equal to 0 line because e looks like this. Okay, so there's actually a horizontal asymptote at y is equal to 0, which prevents it from equaling 0. And think about it, right? If you plug in any negative number into e to the negative 2x, you're going to have e raised to a positive exponent. If you plug in 0, anything raised to an exponent of 0 is going to be 1. And then if you plug in any positive number, then it would be e raised to a negative exponent, which would turn it into 1 over e raised to that exponent. And so it would just be a fraction. So it never equals to 0. Is that part okay? Okay. So now what I have to concentrate is making this here equal to 0. So we can distribute this negative 2, and we get 1 plus 2x minus 2x minus 2x squared equals 0. My 2x's here cancel out. So 1 minus 2x squared equals 0. So now I'm going to solve for x by subtracting 1. So negative 2x squared is equal to negative 1. And then divide by negative 2. So we get x squared is equal to 1/2. And then we square root both sides, which gives me the square root of 1 over the square root of 2. Remember, always plus or minus. So it's plus or minus 1 over square root of 2. Now, this was an actual question from College Board. So when I was working this one out and I got this as my critical numbers, I always look at multiple choice answers frequently while I work to see if anything is starting to connect. You get me? So when I looked at my values here, I can automatically eliminate A and B because those critical numbers don't look anything like mine. Do you get what I mean? The other thing is that these critical numbers here is the square root of 2 over 2, not 1 over the square root of 2, which is because they rationalized it. So I went ahead and did that as well. I multiplied square root of 2 to both the numerator and the denominator, and so my critical numbers are x equals positive square root of 2 over 2 and negative square root of 2 over 2. Is that clear? Okay. Now, how do I know that it's a fraction, which is what you were asking me, right? You don't need a calculator or anything. It's the square root of 2 is going to be a number that's less than 2, right? Because it's the square root of it. So it's going to be like 1 point something. That's all I know. And then if I divide that by 2, that's going to give me another, it's you're dividing a decimal. So it's going to be just another fraction. Do you get what I'm saying? So since those are fractions, if I put it on number line, negative square root of 2 over 2 and positive square root of 2 over 2, here, let me do this in a different color so we don't get confused with all my numbers. In between a negative and a positive, I'm going to plug in 0. To the left of negative square root of 2 over 2, like I said, since this is going to be a fraction, I can use negative 1. Or you can use negative 2, negative 3. It doesn't matter, right? If you want to move farther away just to make sure, you can. And then with positive square root of 2 over 2, then I would just use 1. Yeah? Now, this is my derivative, right? I could use like my f, because we got to test these values. This is e to the negative 2x times, and then what I would rather use instead of this hot mess, I would probably use the 1 minus 2x squared, since we worked that out here and got that what's inside of the parentheses is this. Is that okay? Okay, so if I plug in negative 1, this is going to end, no matter what, e raised to any exponent is going to be a positive number. It's never going to be negative. But either way, if you plug it in, right, e to the negative 2 times negative 1 will be e squared. So that's positive. And then if I plug in negative 1 into this factor, then negative 1 squared is going to be positive. So 1 minus positive 2, 1 minus 2 would be negative. So this is positive times this is negative. So this would be negative. Is that okay? If I get 0, anything raised to an exponent of 0, so here would be 1. And then 1 minus 0 would be positive. So this is positive. At this point, I don't need to keep going because it's asking me about when it's increasing, and you see how it's in here, in between, in the middle. So that's between negative square root of 2 over 2 and positive square root of 2 over 2. Yeah, exactly. What other questions do we have? Okay, I had a feeling that these related rates questions are going to come up. So actually, what I was gonna do the first day when we come back is we're gonna do these in class together. Okay? So that way it'll help us to review those related rates that we need to review before you take the test. You get me? Okay? So I would rather focus more on the previous material. And then since this is more current, we'll do these when I see you guys. Do you know if Monday is an A day or a B day? Fine. Okay, so then we'll look at it together on Tuesday. Okay? All right. That's a good question. I don't know. I don't remember. I would have to see when we get back. It won't be Tuesday though. So, um, I don't even know if it'll be on Thursday. So it could be Thursday or Monday, one of the two. I have to look at the rest of like, because every time we work, I always look to see our timeline when we're gonna finish like before the AP exam. So if I see that if we do the test on Monday, it's gonna cut our time short to review, then it will have to be on Thursday. But I will let you know on Tuesday when I see you guys. Yeah, yeah, because it's only five of us here right now, or six or something. So I would want everybody to review those last questions. Let me see. Is that also related rates? Yeah. So 71 through 74 we'll do together. I mean, it doesn't mean don't try it. You know what I mean? Like try it out and see how far you can get. So that way you can see like where you get stuck and what you need to focus on. Oh, but 72 is not a related rates question. I don't know if you wanted to go over that or not really. Okay. We have a little bit more time, so do you have any other questions? Sure. Can I erase this bit here then? Okay. Someone's really partying it up outside. You can't hear that? No? Okay. All right. Let f of x be a twice differentiable function such that f of 1 is equal to 3 and dy dx is equal to that. What is the value of d squared y over dx squared at x is equal to 1? Okay. So remember that this notation means what? That's right. Good. That's the second derivative. They tell you that dy dx is this. So you already have the first derivative. So you're going to take the derivative of the derivative. Okay. So this I'm just going to label for like just to make my work understandable. I'm going to label it as f prime of x. Okay. Actually, no, I'm not. I'm not going to do that. Ignore that. I'm not doing. We're just going to go ahead and jump right in. Okay. So this, I like to rewrite it. This is 4y squared plus 7x squared raised to the 1/2 because of that square root. So we got to apply the chain rule here. We're going to multiply 1/2 times 4, which is 2. Then leave the inside alone, raised to the negative 1/2. And now multiply by the derivative of the inside, which would be 2y dy dx plus 14x. Is that okay? Okay. Now, this question is kind of annoying, but the good thing is that they want you to find the second derivative when x is 1, and they tell you the y value as well. So that's your coordinate is 1 comma 3. That's what we're going to plug in here. You don't have to stress out trying to rewrite this so that it looks pretty. At the end of the day, you're going to plug in a coordinate and my answer is just going to be one number. So I'm not going to do much in terms of my derivative except for the negative exponent. I'm going to move down to the denominator. So I have the 2 in the numerator, the 2y dy dx plus 14x in the numerator, and then everything is over the square root of y squared plus 7x. Is this part okay? Just the rewriting. Oh, yes, thank you. Okay. And the only other thing I'm going to do is I'm going to plug in dy dx, which is this, because remember that dy dx was given to us. So we got 2 times 2y square root of y squared plus 7x squared plus 14x all over the square root of y squared plus 7x squared. Go away. Okay. Okay. Oh yeah, no, cause it's remember the one half. It's one half times four, not two times four, right? Okay. Okay, so from here, I'm not gonna do anything else. I don't care what else. You can distribute the two if you want. I didn't on my paper. So I'm gonna go ahead and take that coordinate and plug it in. So we got 2 times y, which is the 3, so that's gonna be 6, times the square root of 3 squared, which is 9, plus 7 times 1 squared, so 7, plus 14 times 1, so 14, all over the square root. And then this is the same thing as this one up here, so it'll be 9 plus 7. So I just took this and I took my x and my y and I plugged it in directly into what I got from my derivative. Is that okay? Okay. So 2 times. Now this is the square root of 16, right? So the square root of 16 is 4, right? And then 4 times 6 here is 24 plus 14 all over once more square root of 16, so 4. Is that okay? Okay. 2 times 24 plus 14 is 38 divided by 4. You can do this any number of ways. You can multiply the 2 times 38 and then divide by 4. I can do 2 over 4, which is going to be 2, and then 38 divided by 2 gives me a final answer of 19. Oh, oh my God, my bad. Sorry, sorry, sorry. I just realized I was like, wait, what am I doing? Okay, wait, let me see. Uh, but okay, wait, hold on. Let me come back here. Yeah, because you distributed the two, which is fine. Um, I must have done something. Let me see what I did here. I just want to make sure. I want to know what I did. Okay, but this is fine, right? This derivative here. And then move this down. Oh, you're right. I forgot about this 4. The 4 from here, from the dy dx. Do you see what I mean? It's 2y times dy dx, and the dy dx has that 4. So yeah, it was 2 times 8y square root of y squared plus 7x squared plus 14x over the square root of y squared plus 7x squared. Sorry, Elizabeth. Yeah, I totally forgot about the 4. Did you guys see what I did wrong? Yeah. Okay, so let's do this again. Let's plug in these numbers. So, yeah, that should be fine. Yeah. Okay, so it'd be 2 times 8 times 3, which is 24, times the square root. This is still the same, which is 16 plus 14 all over square root of 16. So that's going to be 24 times 4, which is, why can't I think? 96 plus 14 all over 4. E2. So this is 110 divided by 2, which is, yeah, 55. There you go. Okay, if you guys want, we can do one more. No? Okay. So this is what we'll do. I'm gonna go ahead after this. I'm gonna um, upload it to YouTube and then post the link on Google Classroom. It does take a while to process the video, so I'll just send a remind once it's been uploaded. Those of you that attended, let me make a note right now. Hold on, type this in. This is winter review. Okay, so it's Caitlin, Jenny, um, Elizabeth, Andres, Valentin. Who am I missing? That's it. Did I get everybody? Just 5? Caitlin, Jenny, Elizabeth, Andres, and Valentin. Okay. You guys, all you have to do is make sure that you turn in your review assignment and you're going to get an automatic 100. Okay? So congratulations. Um, and then, yeah, so we'll spend Tuesday just reviewing those last few questions as well as just reviewing stuff in general. I'll let you know when that test is as soon as I look at my lesson plans and all that for the rest of the year. And yeah, have a great last few days of your break. Have a happy new year. I hope you guys all had a very Merry Christmas or whatever you celebrate. I'm done. So the winter assignment will be due on Thursday, right? So I like to give extra time for the winter assignment. If you need more time, you can just turn everything in on Thursday if that helps. Okay, so on Tuesday, I will answer questions from everything that you guys got from me. Okay? Yeah. Any other questions before I let you guys go? No? Okay. Well, thank you guys for taking the time early on a Wednesday during break. I do appreciate it. So I'll see you guys on Tuesday. Bye. Yes, it's gone by so fast. Bye. Me voy a morir.